A quick update on the Unboxing Tomorrow drone project. You might recall that back in the spring of 2020, I featured several projects in software-defined radio communications, followed by a couple of summer projects in machine vision, followed by a return to radio communications projects during the fall. Now that winter is upon us, I figured it's time for another change of pace, this time dealing with robotics and closed-loop control systems, and since aerial drones seem to merge the two pretty well, I figured why not. First, a quick correction to a recent video. In the New Year's video, Embedded Technology Watchlist for 2021 through 2031, I mentioned that gallium nitride and silicon carbide transistors had higher electron mobility than conventional silicon. The term I should have used was actually electron saturation velocity, or simply saturation velocity. The two concepts are similar, however saturation velocity, which is where GaN and SiC do have the advantage, applies mostly to transistors that are in high field conditions. Simply stated, if you ever find yourself driving a transistor into the on state as far as it can get, then you're probably driving electrons or holes to their saturation velocity. It was a strange error for me to make, considering I am evaluating gallium nitride transistors and gallium nitride drivers. But in the same video, I also mentioned how drones and counter-drone technology would have a huge impact over this decade, or at least in my own opinion. My own drone project here is very much in its infancy, and I have to say it's something I've never really done before. Back in the day, I did briefly get involved with ArduPilot, which was a open source, open hardware solution. This project, on the other hand, is basically designing a self-stabilizing drone from scratch, made possible in part thanks to our affiliate TorGuard VPN. VPNs, or virtual private networks, are networking tools that you can use to help protect your online data from hackers and cyber criminals. TorGuard is the VPN that I use for this purpose, and when you sign up using the link in the description, this blog receives a commission at no additional cost to you. Use promo code UNBOXING to receive additional discounts. Among other things, the drone project should also help me evaluate new design tools and techniques for embedded systems that use closed-loop controls. But to focus back on the basics, my number one priority for now is selecting a microprocessor or microcontroller to basically coordinate the whole system. This includes steering the vehicle, communicating with ground equipment, managing the onboard battery, controlling payloads, and detecting fault conditions. So far, the microcontroller of choice looks like the microchip ATSAM D21 microcontroller, which is actually based on a ARM Cortex-M0 architecture. Performance-wise, this would actually put it on the low end of the spectrum, at least in terms of other ARM devices we've seen here so far, but I consider it a good starting point, and if nothing else, it does help that this chip is physically easy for me to solder. ATSAM D21 is also covered by an evaluation tool that I already had in my inventory the whole time, and the text, Atmel ARM Programming for Embedded Systems, was already in my library. There's a lot more to cover, but for now you can find more on my Patreon page, along with the monthly poll and lessons learned on technical builds like this one. The poll for January 2021 wants to know if you have any New Year's resolutions, including upskilling. Stay posted for more electronics, robotics, and communication systems, and as always, have a great day.